Welcome back. Hope you're finding this series useful to you. Time to talk about data science lifecycle in detail. Here is a data science lifecycle diagram I found from Berkeley School of Education website. I thought this would be a good idea to learn the data science lifecycle. So if you notice it, the image represents 5 stages of the data science lifecycle: capture, maintain, process, analyze, and communicate. All right, so let's deep dive into some of the aspects. And this is again from another article, pretty much the same what I have shared in the previous slide, but slight differences here and there. That's expected pretty much, right? Now, the first in the list is data acquisition. So you need data before you do anything, right? Primarily step in the life cycle of data science project is to first identify the person who knows what data to acquire in an organization, right? And then when to acquire based on the question to be answered. The person need not necessarily be a data scientist, but anyone who knows the real difference between various available data sets and making those hard-hitting decisions about data investment strategy for an organization. I would say that would be the right person of your choice for doing this job. Data science project begins with identifying various data sources, which could be logs from web servers, social media data, data from online repositories like census datasets, data stream from online sources via APIs, web scraping, or data could be present in an Excel or can come from any other sources, right? Data acquisition involves acquiring data from all the identified internal and external sources that can help answer the business question. A major challenge that data professionals often encounter in data acquisition step is tracking where each data slice comes from, whether the data slice acquired is up to date or not. Big question, right? It is important to track this information during the entire life cycle of the data science project, as the data might have to be reacquired to test another hypothesis or run any other updated experiments. So next on the list is data preparation, or you can call it as data cleansing phase, right? This is the time-taking process, includes identification of various data quality issues. Data acquired in the first step of a data science project usually not in a usable format to run the required analysis and might certain missing data entries, right? Inconsistencies, semantic errors, and so on. So after acquired the data scientists should clean and reformat the data by manually editing it in the spreadsheet or by writing some codes around it, right? This step of the data science project lifecycle does not really produce any meaningful insights. It's just a cleaning exercise, right? And then preparing the data around it. However, through regular data cleaning, and data scientists can easily identify what are those shortfalls exist in the data acquisition process, what assumptions they should make it, and what models they can apply to produce analysis results. Data after reformatting can be converted into JSON or CSV or into a spreadsheet, an Excel file, any other format that makes it easy to load into one of the data science tools. Exploratory data analysis forms an integral part at this stage. A summarization of the cleanup data can help identify outliers, as I mentioned earlier, anomalies, and patterns that can be usable in the subsequent steps. This is the step that helps data scientists answer the question on as to what do they actually want to do with this data. Exploratory data analysis is an attitude. That's interesting. A state of flexibility, a willingness to look for those things that we believe are not there, as well as those we believe to be there. And this has been told by John Tukey, an American mathematician for that matter. So hypothesis and modeling is the third step. This is a core activity of a data science project that requires writing, running some refining programs to analyze and derive meaningful business insights from data. Often these programs are written in languages like Python or MATLAB or Perl. Diverse machine learning techniques are applied to the data to identify the machine learning model that best fits the business needs. All the contending machine learning models are trained with the training data sets. Now, on the fourth on the list is evaluation and interpretation. There are different evaluation metrics for different performance metrics. For instance, if machine learning model aims to classify spam emails, then performance metrics like average accuracy and log loss has to be considered, isn't it? A common question that professionals often have when evaluating performance of a machine learning model is that which data set they should use to measure the performance of the machine learning model. Looking at the performance metrics on the trained data set is helpful, but not always, right? Because of the numbers obtained might be overly optimistic as the model is already adapted to the training data set. Machine learning model performances should be measured and compared, while validation and test sets to identify the best model based on the model accuracy and overfitting. All the above steps, what I have told right now from step 1 to step 4, are iterated as data is acquired continuously and business understanding become much cleaner now. Now, the last few steps is like, deployment. Machine learning models might have to be recoded before deployment because data scientists might favor Python programming language, but the production environment supports Java. Possible? Yes. After this, the machine learning models are first deployed in a pre-production or test environment before even actually deploying them into the production. Now, the second last or the sixth one in the list is operations and maintenance. This step involves developing a plan for monitoring and maintaining the data science project in the long run. The model performance is monitored and performance downgrade is clearly monitored in this phase. Data scientists can archive their learnings from a specific data science project for shared learning and to speed up similar data science projects in the near future, or share with the juniors, who can learn this entire process, or creating a knowledge repository for that matter. Optimization is the last one on the list. This is the final phase of any data science project that involves retraining the machine learning model in production whenever there are new data sources coming up, or taking necessary steps to keep up with the performance of the machine learning model. Having a well-defined workflow for any data science project is less frustrating for any data professionals to work on. I'm sure you will agree to it. The life cycle of a data science project mentioned above is not definitive and can be altered accordingly to improve the efficiency of a specific data science project as per business requirements. So basically this list, what I have shared with you, gives you a fair amount of understanding on the workflow and the life cycle, but not necessarily or limited to these only steps what I have outlined here. It can vary from project to project and from convenience perspective and maybe organization or the data scientist's decision, right? So yeah, so that's pretty much the life cycle of a data science project. With that, I would like to thank you for watching this video and see you soon in the next video. Thank you.